A linear equation is any equation equivalent to ax is equal to b. Here we're assuming that the value a is not equal to 0. I'd say the main takeaway is that the exponent on the variable, in this case x, is 1. So to solve any linear equation, we can add, subtract, multiply, and divide both sides of the equation by equal amounts. So to just demonstrate this point, I have 4 separate equations here that are very simple to solve. So like if you look at these first two, if you want to get x by itself, this can be simply done by either adding or subtracting something from both sides of your equation. So with this very first one here, to isolate x, I need to subtract 5 from both sides. So we can subtract 5. Adding them together is x is equal to -4. And you compare that to the equation that is over here. If you're looking to get x by itself and you want to get rid of this -3, you can add 3 to both sides. So plus 3 on the left, plus 3 on the right. X is equal to 7. So again, the idea being by adding or subtracting, we are isolating x. Now, if something is attached by multiplication, like here I have 2x is equal to 14, to get rid of this 2, I'm going to divide both sides by 2. So I'm just going to copy the equation over, and then on the left, I'll put a division, and on the right as well, with 2 in the denominator. What this does for us is cancel the 2, leaving us with just x on the left, and 14 over 2 is 7 on the right. And in this last case, if you have a number in the denominator that you'd like to get rid of, well, you can multiply that to both sides. So that would look something like this. I see there's a -6 down here that I'd like to cancel. I'm going to multiply both sides by -6, being careful to use parentheses. And maybe I'll put some parentheses around this as well. If you think of this as a fraction, the -6's cancel, and the only stuff that is left over here is just a 1, which we don't have to write, and so we get x is equal to, and on the other side of my equation, the negatives cancel. 6 times 8 is 48. So within these 4 basic linear equations, it illustrates what we can do to solve an equation. We can add, subtract, multiply, and divide the same amounts to both sides of an equation. So let's use these ideas to solve the linear equation in example 1. So kind of just like scanning across here, I'm seeing that x is only to the first power in every single term. So this, I think, is definitely a linear equation. So I should be able to somehow get x by itself and a number on the other side. But we need to do something first. On the left and on the right, I think I have to distribute things to get rid of the parentheses before I can start combining some like terms. So let's begin there. I'm going to distribute this -2 into the parentheses, and if we do that, we get -2x minus 2, and I get this plus 4x minus 7. And on the other side of my equation, I have 2 sets of parentheses, so I'll distribute in the 7 and this positive 2. If I do that, I get 7x minus 7 plus 2 minus 6x. So now that the parentheses are gone, I can examine both sides and say maybe there are some like terms that I can combine. So I have a minus 2x and a 4x. I know that is equal to a positive 2x. And I have a -2 and a -7, so that's -9. On the other side, I have 7x and a minus 6x, which gives me a 1x, so I'll just put x. Then I have -7 plus 2, which is -5. Okay, it's at this point where I can use all the strategies from the previous example. That is, if I'm going to get x's by itself, I can't have both an x and a number on this side. So let's get rid of this number. If I'm subtracting 9, I can add 9 to both sides, resulting in 2x is equal to x plus 4. And then, okay, on the right side, I have a number, but I don't want this x, so I can subtract x from both sides. And I'm left with x is equal to 4. And once we have this, we've isolated x, and 4 is the answer. We could take this value and go back to the original equation and put it in place of all the x's to make sure the left side is equal to the right side. But for now, we're just going to leave it at this, that the answer is equal to 4. And for example 2, again, same idea. I have this linear equation, and I want to isolate, in this case, the variable I'm using as y. So as a strategy, if you're dealing with a fraction, like here we have a half, something like with a 4 in the denominator and 8, a good approach would be to try to cancel the denominators before moving forward. So to do that, I'm going to use a least common denominator. So if we have 2, 4, and 8, I know I can multiply each of those to get to the value of 8. 8 is the least common denominator for those three fractions. So my approach is going to be to multiply both sides of my equation by 8. It'll cancel every single denominator. In some cases, some stuff will be left over, but at least the denominators will be gone. So I'm going to try to be careful when I write that out, but I'm multiplying both sides by the same amount. That is, I have 8 times the left side, and I have 8 times the right side. And it might be useful, since we have fractions, to write this as 8 over 1 if you'd like. Okay, as my next step, I'm going to distribute this 8 over 1 into the parentheses. So this whole thing gets multiplied here as well as here. And there's really nothing being distributed. You could actually just rewrite this as negative 8 over 1 times this last fraction. But going through this will multiply right here to give us 8 over 1 times y plus 1 over 2 minus, and then it gets multiplied here, and we have 8 over 1 times 3 over 4. This is equal to, I have three values here, 8 over 1, negative 1, and this fraction. I'm going to choose to write this as negative 8 over 1 times 1 minus 3y over 8. It is at this point where we can now cancel the denominators. So let's see. 2 goes into 8 4 times. Notice now that the denominator is just 1 times 1, or just 1, meaning we don't have to write it when we simplify this expression. 4 goes into itself once, it goes into 8 twice, again noting that the denominator is just going to be 1. And the last one here is 8 goes into itself once, and again the denominator is gone. All right, I gotta be careful when I simplify this portion here. This is 4 times y plus 1. I'm going to use parentheses around the y plus 1 because 4 is being multiplied to this whole thing. So like I said, 4 times y plus 1. Then I get minus. I have 2 times 3, which is 6. Again, I'm not writing the denominators because all of the denominators are just 1. On the right side, this negative is still here. This is just 1 over 1, which I don't need to write. I don't need to write this one either, but just being careful, this negative is being multiplied to 1 minus 3y. I'm going to use parentheses again and put minus 1 minus 3y. So it's quite a bit of work to get there, but at least the fractions are gone. In fact, I think it's okay even to start with this step before I started canceling. You could just put an 8 over 1 next to each fraction. Okay, to solve this for y, I'm going to distribute the 4 and distribute this negative. So let me draw that in. The 4 gets multiplied in, as well as this negative 1. I have 4y plus 4 minus 6 is equal to negative 1 plus 3y. On the left, I can simplify a little bit. I get 4y minus 2 is equal to negative 1 plus 3y. And now we're at this point where we have to start moving things from the left or right side of the equation. So I'm going to add 2 to both sides and then subtract 3y from both sides. Let me put that in here. I'll add 2. This gives us 4y is equal to 1 plus 3y. I'll then subtract 3y from both sides, and I'm left with y is equal to 1. Again, we could plug this back into the original equation just to make sure the left side is equal to the right side, but for this problem, I just wanted to go through the process of solving a more complicated linear equation.